Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of inverse trig integration. Let's look at this one. Let's make it more fun. All right, talk to me. Any ideas? Hey, look at that. Good job. U sub is the correct answer, but you have to be careful what you let u equal, because I can't let u equal this whole thing because the derivative of x to the fourth is what? You all right, buddy? Are you getting sick on me? I'm sorry. Get some rest. You have plenty of time to rest up and study, get ahead. You should be reviewing for your final over break, okay? Go through your old exams, old quizzes. Good. So you see that at this point, that's not going to work because I don't have an x cubed term up here. I would need an x cubed, and because I don't have an x cubed up there, I can't do that substitution. And actually, I should have had x to the fourth plus 4. Good. That way, when you let du equals 2x dx, and now we have an x to the first power, and it can cancel with that x, so we're in business. So when we do that, I'm going to solve for dx, and it's going to become the x I did nothing with before, and then the x to the fourth plus 4. Well, x to the fourth is nothing more than x squared squared, right? Good, so it's going to be u squared plus 4, and then du over 2x. The x's will cancel, and the 1/2 can come out in front. So you're going to get 1/2 integral of du over u squared plus 4. You know what that integral equals? What's the arctangent formula? Right, because it's the only one that has a plus sign, and it's the only one without a square root. Is this what you're telling me to write? Look at your variable. Were we in terms of x? Okay, and also, is it arctangent of box or is it box squared? I think it's box, right? So it would just be u. Okay. Now, something I didn't do here was change the bounds. You can do this. You can do this and then plug back in x squared if you want, but that's kind of cheating. It's not that hard to change the bounds. If you look at this, this is the relationship between u and x right here. You've established it. So you can say when x equals 0, well, let's plug in. Let's figure out what u equals. Well, 0 squared is what? 0. And then when x equals 1, what are we going to get? 1, right? So just by coincidence, I picked two bounds that did not change when we did a substitution. Usually they do change. Okay? So in this case, when I plug in, ooh, I should have made it a 2. It's okay. I made up this problem. Anyway, so when I plug in, I evaluate the bounds, and it's always which one minus which one. Is it top minus bottom or bottom minus top? Good. Do you have any questions over this problem, Johnny? No, please ask. I can edit it out if you want me to. Whatever you tell me to edit out, I will take out. I don't want you to feel just because we're recording. Uh, you could. Well, no, actually, you can't. You can, but once you change the bounds, like we just did, right? We did change the bounds. It's okay to leave your answer in terms of u. You don't have to do that final step of going back in terms of x, because you've now changed the bounds in terms of u. Okay, so it saves you a step. All right. So the arctangent of 0 is 0, and we don't know any angle that hasn't. I mean, we don't know. It's not one of the major angles we deal with that has a tangent of 1/2. So you can put that in your calculator and get an angle if you want to. But that would be your answer, mainly there. Do you have any questions over that? So I hope this has opened your eyes to the complexity level. This is not even an advanced problem, I wouldn't say, because most people, once they see these, they're okay with them. So keep your eye out for a substitution, then inverse trig, like in this problem. Next, in the more advanced problems, what we're going to do is look at the completing the square version of these problems. So if you cannot complete the square, you forgot your rules, my advice to you is to go back and review. That way when you look at the integration part of the video, you won't be slowed down by the algebra. Unfortunately, that's the biggest problem with people in calculus is the algebra and the trig, not the calculus. So practice, practice, practice. Thank you and have a nice day.